everybody. Welcome, and welcome back. If you are new, it is lovely to have you here. I can see a bunch of you in the chat, just spamming the chat. I am absolutely loving it. But yeah, welcome to Monday Night Live. Sorry, we're starting a bit late. I was just running late from work, really. But yeah, it's lovely to have you here. Today we're gonna have some chemistry, some physics, and I believe also math with Will. But until we kick that off, I have a couple of questions for you. Actually, just one question. If you could just wake up tomorrow with any skill that you have, what would you choose to master? What would you want to master if you can master any skill? You wake up tomorrow and immediately you are the person for that stuff. I think with my 5'6", actually lies, 5'4" personality, I dare to say I want to master some basketballs, and I want to be great in basketball. So that is my question. That is my answer. I want to be the best basketballer ever, better than Kobe, better than anybody. Some people are saying bench to 225. Fair enough. Yeah, that would be sick. That would be sick. How much can you bench now? Be smart at everything. What's the question? Oh, that's the question over there. I'm assuming you've asked that before. Languages are great at every sport. Yeah. What language would you pick for? Yeah. I think if I go for language, it has to be either Spanish or French. It has to be that. Being smart, but what would you be smart at? Would you be like great at chemistry, at biology, or would you be the math person? Or which subjects would you want to be smart in? Because anything I dream of. Yeah, anything you dream of, just dream a skill, Elizabeth. And if you can just wake up tomorrow and have that skill, what would it be? But yeah, keep thinking great, because it's just like it's a silly thing. So you can be anything really. You can be the next, I don't know, the next what? You lift over 20 kgs. That's good. That's good. So one day you bench 225. Okay, brilliant. You guys keep thinking on that, and we're gonna hear some gems from Arnold on how to read and what ways are better to read and how to better know ourselves. And I will catch you guys in a minute.
The reason why we do the Study Safari, if you are new here, it's an opportunity for you to discover and unlock the secrets to how to study properly. You don't learn this in school, but we teach it to you so that you know how to make the most of your study sessions and ultimately get the goal that you are looking for. Today, we're going to be looking at self-awareness and the value of self-awareness. So bear with me as I share my screen. Okay, so we are going to be looking at study success and self-awareness. Now, ultimately, you may not actually realize this, but as a student, it's really important to be self-aware. What actually is self-aware? Well, being self-aware, sorry. Have you ever asked yourself, well, who actually am I? What do I want to become? Self-awareness is about knowing your strengths and your weaknesses. It's finding your lane and understanding how you best do things, where you should best be placed, all right? It's about understanding your present limitations, the things that are preventing you from moving forward, and then also what you want and what you don't want. That's what self-awareness is. If you are not self-aware, you will not succeed. You will not get the grade that you're looking for if you are not self-aware. You need to be self-aware in order to understand. I'd love to take a moment here. In the chat, why don't you put in, I believe there are 4 differences in this image. What are the 4 differences in this image? If it's possible for the hosts to pause, great. But if not, then please put in the chat what the 4 differences in this particular image are. I'll give you a bit of time to be able to do that, and then I'm going to move on. See, the reason why I'm doing this is because while there are a lot of similarities in these two images, each one is actually unique. In the same way, you students who are watching this, you have similarities to each other, but you're all still quite unique. You're authentic, all right? You are a unique individual, but you can't be authentic if you imitate someone else. I'd love to hear on the chat. Why don't you put in the chat right now? Have you ever been in a situation where there's that really smart student in school, in your class? Maybe it's you. And you might think, oh, if I just imitate them, if I just do what they do, then I'll end up getting the grade that I'm looking for. Alternatively, you might think if people just did what I did, then they would get the grade that they're looking for. Well, it just doesn't work like that. We can definitely learn from others, but we can't be others. We can't be someone else. It doesn't work like that. You've got to understand how you are and how you work. So why are we learning this? Well, the reason why we're learning this is self-awareness actually leads to increased confidence. I believe there are some of you here who don't feel confident about the way that you're studying. You don't feel confident about whether you're going to reach your goal and get the grade that you're looking for. Well, being self-aware allows you to increase your grades. You might think, well, how does it? But ultimately it does. It allows you to increase your grade. So how is it then that we can know ourselves better? Well, firstly, there are top 5 secrets. If you just adopt this mindset, then you will know yourself better. And the first one is to make sure that you have faith. You've just got to believe ultimately, do you know what? Knowing yourself will make you a more effective student. You just got to believe that if you know yourself, you're more likely to get the grade that you're looking for. Just to believe that, because then you'll put the work in to get to know yourself. Then you've got to learn to prioritize your time. You've got to set time aside for being self-aware. And we actually do provide you with something so that you can set time aside for it. You've got to work with others in order to be self-aware. You've got to find out how they see you, how they perceive you, because sometimes your own perception of yourself is different to other people's perceptions of you. And then you've also got to learn to ask questions as well. So we're going to be looking at prioritizing. See, being self-aware is actually a lifelong journey. It's not something that all of a sudden you are self-aware. You're constantly changing, so you constantly have to do exercises to understand yourself a little bit more. And there are so many things that you've got to do to learn, or there are so many things that you've got to learn about yourself, because you're a complicated human, as we all are. So you've got to learn, how do you best learn? What do you need to know? What's your personality like? You've got to learn what your strengths are. You've got to learn what job prospects you're going for, and so on. Now, unfortunately, I don't know. It's up to you to decide. But we don't have the time to be able to cover all of these things. And I am not your life counselor. I am here to help you in your studies. So what we do cover for you is how you best learn and what you need to know. That's what we cover for you. Today, we're going to be focusing primarily on how you best learn. How do you best learn? Now, the journey of learning self-awareness is best done through what's known as VARK, V-A-R-K, visual, auditory, reading, writing, and kinesthetic. So all of you will fall into one of these categories. In all honesty, you do express all of them in the way that you learn, but when it comes to your studies, you tend to have a bias toward one of them: visual, auditory, reading, writing, kinesthetic. Now, let's take a look at Muhammad Ali, who is a boxer. Okay, he's 1.91 meters. He's a tall person, taller than me. I'm 180 centimeters, so I'm 1.8. He's 11 centimeters taller than me. He's heavyweight champion, all right, in boxing. Now we have Mike Tyson. Mike Tyson also, right, was a heavyweight champion, but he's significantly shorter than Muhammad Ali. They have to learn to fight differently because of their differences. They're similar because they're both boxers, they both love boxing and so on, but their bodies are different. So they have to learn to fight in a way that suits them. Muhammad Ali has to learn to fight in a way that suits him. Mike Tyson has to learn to fight in a way that suits him. And if Mike Tyson learned to fight like Muhammad Ali, then Mike Tyson wouldn't be heavyweight champion. It wouldn't have worked because he doesn't have the body to accommodate his style. He can learn from him, definitely, but he can't be him. It just doesn't work like that. So visual learners have a preference to gathering information through looking at diagrams, maps, charts, and so on. All right, that's how visual learners tend to learn best. And we're going to be covering visual learners and the revision techniques for visual learners a little bit later. Then you've got auditory learners. Now, auditory learners will tend to learn best through lectures, through discussions and recordings as well. All right, so auditory learners tend to love these sessions, tend to love coming to our classes because they can engage in the chat and they can ask questions and the questions can be answered and they can have conversations, and that's how they learn. Visual learners tend to learn well in our sessions because of the fact that, it's very colorful, it's easy to remember, and so on. Then you've got reading writing learners. Now, reading writing learners will tend to just read books, will use presentations and read articles. You tend to love learning through writing lists as well. That tends to be a big deal for reading writing learners. I'm a reading writing learner. As you can see, there's a lot of lists here, which is helpful for reading writing learners. And then you've got kinesthetic learners. Kinesthetic learners learn through practicals, video demonstrations, case studies, interviews, and graphs as well. Right? That's how you all learn differently. Some of you are visual learners, you're auditory learners, kinesthetic and reading writing learners. Why don't you put in the chat what type of learner you are, just so that we can see the differences that we have here. So you can take the quiz by going to hubspacelearning.com/quizzes/vark-quiz. And then you can find out how you best learn. The host is able to put that on the chat right now. But I have some questions for you, and maybe the host will be able to work with you in answering these questions. So have you taken the study skills quiz? What was your result? If you didn't put it in the chat already, put it now. What were your results before? Second question is, how has your understanding of yourself, how do you feel that's made you a better student? How has self-awareness made you a better student? What would you say to those questions? Great, we're going to stop there and I'm going to hand it back to the host. See you later.
All right, thanks Arnold for that. I am going to assume right now, every one of you, I can see 32 of you in the live. I'm going to assume that every one of you has actually done the test. So let me know if knowing it actually had helped and if you're following one of the tips that Arnold is saying. You're going to tell us about that. And while you do that, I'm going to bring Ryan up and he is going to tell us what skill he would want to learn if he was to wake up tomorrow and be a pro at something. What would he be? I know, hard question. How are you though?
Fantastic questions, and I'm just not ready for them. I forget I have.
Well, I'll tell you what I said. What you think? Yeah, I said I'm gonna dare to believe I am 5'4", and I'm not horrible. But one of the sports that I struggle with is basketball, and I love basketball for some reason. Maybe because I'm short. I don't know. I'm not good at it, so I'd say I want to wake up and be really great at it because that's a sport that I can't get around to. Yeah,
that's a great one.
That's what I said. So,
I think piano for me.
Piano. Okay. Oh,
like,
nice.
Yeah, I'd love to just be able to sit down at piano and just like get a song I've never learned and just like, this is how it goes and play it perfectly.
Yeah.
That'd be sick.
Perfectly. And be like, actually, I'm gonna play it in C# or whatever they. Yeah. Ooh, I like that. Would you ever perform though?
Yeah. I would perform all the time if I was good.
Nice, yeah. Do you perform now? I know you play like guitar and stuff.
No, I want to do a open mic night in Brighton at some point.
Yeah.
But I need to get more confident first.
Yeah. Maybe you can start by performing for us. I don't know what the chat's gonna say.
No.
Never. Just like jamming in chemistry.
Yeah.
Yeah. People are saying, well, some people want it to be great at. Somebody said they want to bench 225.
Okay.
Yeah. Some people
Just
say
be
you want to go over
massive.
20 kg.
Fair enough.
Yeah. 20 kg is not that hard though.
What's that?
Somebody said they want to lift 20 kg. I said if you've worked for maybe 2 months, you might get there.
It depends what kind of lift, I guess.
That is true. That is true.
Yeah.
Yeah. People just want to be smart, really. We have like great people.
Yeah. It'd be cool to just be like really, really smart, like just a master of something. Like if you got really good at like quizzes, you could make so much money.
Yeah.
Just go on like Mastermind or something.
Yeah.
Pointless.
Oh yeah. The chaser
really,
and stuff like that.
Yeah.
Oh yeah. Yeah. I think I might change my into that because that'd be great.
That'd be really fun.
That'd be really cool. Right, let's get to chemistry, and I'll see you guys in a minute.
That's a good point. Chemistry. Woo. Yeah. Monday morning. It's not morning. It's Monday evening. Welcome. Yeah, we're going to do chemistry. We were last week. We were talking about paper chromatography, and people were asking that we could maybe do some practice questions at the beginning of today. So I've got a bunch of practice exam style questions for us to go through today, and then if we finish them all, then we can move on with the next topic, which is just another one of our practicals, test for anions. Or no, we did do anions, so we'll do cations. But yeah, so it all depends on if we get through these. One thing I really did notice, guys, when going through and finding chromatography style questions is no matter what level, they are all kind of pretty similar. They all ask fairly similar questions. So I'll tell you a bit more what I mean as we go through. But this will give you a chance to ask some chromatography questions, and doing some calculations of RF values. So I say we just get started. You guys, I hope you're ready. Let me share my screen. And hopefully you can all see this nice and clearly. I can zoom in. Let me zoom in just a tad so you can see it nice and clearly. There you go. So the question is, a student investigated a food coloring using paper chromatography. This is the method they used. They put a spot of food coloring X on the start line. They put spots of 3 separate dyes, A, B, and C, on the start line as well. And then they place the bottom of the paper in the water and leave it for several minutes. This is what it sort of looks like. But there are 2 mistakes in this setup. What are our 2 mistakes? And it's given you multiple choice. So the option 1 is the lid is on the beaker. Option 2 is the paper did not touch the bottom of the beaker. Number 3 is spots are too small. I don't know if I was counting them out. The next one is the start line was drawn in ink. And the last one is the water level is above the spots. So there are 2 mistakes. Which 2 are they? Let me know. Chuck it on the chat. Lee, stop using the chat for bad jokes and stop being sexist. I can't believe I have to actually say that in one of my lessons. It's kind of embarrassing. So let's just focus up. We're doing chemistry now. Which two mistakes did they make setting up this experiment? It's multiple choice, so have a look through, read through them again. If you want me to read through them again out loud, if you can't see them, let me know. No worries, Lee. Let's just remember there are a lot of people on here, and we don't want to cause anyone offense. And we are, after all, here to learn. So it's all right. All right, we got a bunch of people responding. Let's get some more, guys. Come on. Let's get some more responses to this. I'm loving how many people are responding. Really good. Yeah, I'm seeing loads of people get this right. Absolutely. So the two big mistakes they made here is that the start line was drawn in ink and that the water level was above the spots. So the reason why, if you're not sure why these were the issues, let's go now. So the issue with the start line being drawn in ink is simply that ink is soluble. So even in water, or if we use some other solvent, perhaps like ethanol or something like that, ink is soluble, so it will dissolve into the water, into the solvent as well, and then it will also travel up the chromatography paper, which will absolutely ruin your result. It will be like just a black wall sort of rising up through it. You won't be able to see any of your dyes, so it's pointless. So we use pencil. Pencil is insoluble, so we use a pencil as our start line. And then we also want to put the water level below the spots so that when the water moves up the paper, it takes the spots with it. If we put the spots in the water, they will just dissolve straight into the water down here, and we'll get a murky mess of all the things mixing together, and then that may slowly rise and we might get like a sort of rainbow color on here, but again, no results. So really important when you set up your chromatography paper, we do that start line in pencil, and we do that start line above the water line, so above where the water goes up to. The lid, absolutely fine, really good. Stops the solvent from evaporating out. We want to keep that solvent in. The paper did not touch the bottom of the beaker. It says up here that they placed the bottom of the paper in the water. It's absolutely fine if it doesn't touch the bottom, as long as the start line is above that water line. It does not need to touch the bottom of the glass. And spots were too small. They're absolutely fine. That one's absolutely easy. Let's move on to the next question. So another student set up the experiment correctly, did not make those mistakes, and got these results. So the first question is, how many dyes are there in X? So in our X that we're testing for, how many dyes are there in it? Nice and easy one. Let's go. We're doing chromatography, Joshua. Join on in. How many dyes are there in X? Yeah, awesome. 3. 100%. We got 3 dots. We got 1, 2, 3. I think the only tricky thing about that is that this middle one, doesn't line up to any of the other ones. So some people may not have counted it, but none of you fell for that. So absolutely right. It's 3. Oh, they didn't even have 2 as an option. So yeah, you're always going to be fine with that. Nice and easy. Which die, A, B, or C, is not in X? These are quite easy, guys. I'm not going to lie. But there are, as I said, there are a lot of similar sort of questions like this in exams. Some might be a bit trickier, but they're all along these sort of lines. Just noticing what the makeup is and so on. Yeah, which of the dies is not in X? Chuck it on the chat. We got so many people here today. Fantastic to see. Well done, everyone. If anyone's new, welcome. And please get involved in the chat. If you're really not sure about anything, you've got to let me know, and I will help you out as best I can. But I need to know first. So get involved in the chat. That's all I would say. Yeah, absolutely fantastic. A, exactly. So we've got C goes up here. So we've got C. B up here. These two line up. These two line up. The A does not line up with anything, so it is A. And that is a fantastic A. All right, so using figure 2 to complete the table below, calculate the RF value for the die A. So I went ahead and done it for you because you obviously can't measure this out. So we're working with the distance moved by A is 38 millimeters. Remember, it's in millimeters. And the distance from the start line to the solvent front is 102 millimeters. What is our RF value? And they've given you the equation here, so I'll let you guys chuck in your answers. Have a go. Even if you're not sure, have a guess. What do you think the answer might be? And I need your answer to 2 significant figures. This is an exact sort of thing where people lose marks. This is a 5-mark question. You'd get 1 for doing these 2. And then you'd get 1 for writing out your equation. You'd get 1 for the answer. And you'd get another 1 for putting it in 2 significant figures. If you do not do those 2 significant figures, you've just thrown away a mark for no reason. So let's have your answer in 2 significant figures, please. Right, let me do a quick calculation myself because I haven't actually done it yet. This is also a new phone, so I don't actually know where the calculator is on it, so it might take me a while, which gives you guys even more time. Ooh. All right. Getting loads of answers in, though. Love to see it. Oh, lovely, lovely. Let's go through it now. It seems like a lot of people are chucking in their answers. So nice and easy. We're going to do that 38. Distance moved by die A is 38 millimeters. We're going to divide that by 102 millimeters. And we get 0.3725, blah, 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 going on for a while. So we'll leave it there. That's our answer. You'd get a mark for that, but then an extra mark comes from putting it into 2 significant figures. 2 significant figures, we go, the first 0 doesn't count. as a significant figure. So we go to the 3, that's 1, 2. So we round it to the nearest this one. As the next one is 2, so we round it down. So it'll be 0.37 exactly. Absolutely well done. I'm just going to quickly check the mark scheme to make sure I haven't made any silly errors. 0.37, bang on. By putting 0.37 on its own, you will automatically get 5 marks. But I'd still recommend you write the thing out. So you write out that you're doing 38 divided by 102. You get this, and then you show you rounding. Just in case you make a mistake in the rounding part, if you rounded that wrong and you put the wrong answer here, you get no marks if you didn't write anything down. So write everything down, get those marks. It is a Samsung, I think. I'm not very good with technology, but yeah, I think it's a Samsung. It's A34 or something like that. They're numbered weirdly. I don't really know. All right, so that's that question. Got a bit of more of a trickier one, although not that tricky. It's just, can everyone make sure they know this equation? I'm not going to rewrite it for the next couple, and they're not going to give it to you in the next couple. So if you're not sure how to calculate the RF value, write it down now, or forever hold your peace. I'll give you a minute to quickly write that down. Yeah, I know. 5 marks for a question like that. That's just handing you marks. That's lovely. Can't complain about that, can we, Josh? All right. Hoping all of you wrote that down, so let's share this one instead. So just to show you guys, literally, this is from a harder paper, and it almost has the exact same question on. Rather than it being multiple choice, this time you have to write and describe the 2 errors they make, which are the exact same errors that you see that were on the last one, for 4 marks. So if you identify the errors and what issues they cause, that is 4 marks. That's lovely. So, and you see now that they write really similar sort of questions about this. So hopefully you guys, if a chromatography question comes up, you'll be able to nail it. But let's start here. Let's start with question B. So someone set it up correctly without making those errors again. And the chromatogram is shown in diagram 2. What do the results tell you about the composition of our black food coloring? So the black is the one we're testing. It's here. I'll put that X there again. That's where it started. So this is our black food coloring. What can we learn about the composition of our black food coloring from this chromatogram? What can we learn about our black food coloring? And remember, it's 2 marks, so I want 2 points. Two marks, 2 points. Let's go. You need to make another point, Lee Amelia Rain. You've only made 1 point, you would get 1 mark. For that, let's get a second mark. Gosh, I'm just good at dancing. What can I say? Come on, guys. You guys were getting so involved in those earlier questions. Let's go. All right, lovely, great stuff. Well done, everyone, for chucking on an answer. Let's go through. So, according to the mark scheme, you'll get 1 mark for saying, as many of you, if not all of you, pointed out, it contains, what is it, A and E? A and E. I have fun. That gets you 1 mark, as I said, and then the next mark contains, it also contains an unknown dye, which a couple of you got really well done. So we got 2 known substances in our black food coloring, and then we got 1 up here that we do not know. A lot of you said things like it's impure. That doesn't really mean anything in this context, so try and avoid using purity in terms of this. Purity more means that when we got something like the example I used last time is if we react magnesium and oxygen together, our product will contain only magnesium and oxygen atoms in it. If there are any impurities, if there's things like carbon or something else that's been cooked in there, maybe different metals, maybe that are in there as well, then that makes it impure. If it's pure, it will have only magnesium and oxygen atoms in it. Which has nothing to do with this. We're trying to separate a mixture. So we learn about our composition from our chromatogram, and we can read off A and E are in it, and there is 1 unknown. That is our 2 marks. And then we're going to use diagram 2 to complete table 1. I've done that for you. And we are going to calculate the RF value for C. So what is the RF value for C? So we've got the distance moved by C here and the distance from the start line to the solvent front here. What is our RF value? Chuck it in. And it's not asking you to round it to any significant figure or anything. I'm not sure if you'll need to. I haven't done it. But yeah, chuck it on in the chat. Let me know what you get. Amelia, that was so quick in there. Like I just gone back onto the chat to see if anyone was still chatting about some rubbish, and you had already put your answer in. Fantastic. Well done, everyone. Really good. Pouring in. I mean, I don't know if you're right yet, but I'd love to see it. Loving this, guys. So many people answering. It's really good. Let's have a look. So from the last time, we know our RF value is distance moved by the dye. RF equals distance moved by dye divided by distance moved by solvent. Yeah. So that's the calculation we're doing. So that is 18 divided by 45, which equals, I think, as everyone said, 0.4. Love it. Well done, guys. Fantastic. Yeah, let's do this. Let's do this question. So we calculated 0.4 as our RF value. And now we got here another table. Table 2 gives the results of chromatography experiments that were carried out on some known food colorings. Food colors. Using the same solvent as the one the students used. So looking at table 2, which of these food colors could be color C from our chromatogram? Which one could be C? And why? So this is a 2-mark question. So which one it is and why? 2 marks. Speedy answers coming in again. Love it. Oh, you know what I should have done? I should have. Oh, sorry, guys. I should have blocked out this whole RF value and made you calculate the RF values for each of them and then tell me which one it was. That would have been a lot more fun for you guys and a lot more practice doing RF values. Next time, I will think ahead. I'm sorry. Loving seeing the answers though, guys. Fantastic. So our RF value for C was 0.4. And the RF value for fast red is also 0.4. So yeah, I would say fast red, that's for 1 mark, has same RF value for the 2nd mark. Let's see what the next question is. We can finish this off. It's just 1 mark, so I'm sure you guys can do it. 2 types of chromatography are gas chromatography and paper chromatography. Give one advantage of gas chromatography compared with paper chromatography. Oh, we didn't actually talk about gas chromatography before. But does anyone have any ideas? Absolutely fine if not, because we didn't talk about gas chromatography at all. But if you guys can have a guess of why gas chromatography might be better, or should we just move on? Let's move on. We haven't talked about gas chromatography, so I don't think there's any point guessing. Yeah, more sensitive would have absolutely got you a mark though, so love it. Shows that even if you're not sure, if you have a guess, you might get the mark. So really well done. Yeah. We won't do that, but fantastic. All right, and then we'll do one last one. They're all really similar, guys. Like, again, this is from an even harder paper, and again, it has almost the exact same question. Wait, this is the exact same question. Like, exactly. With different numbers though. So here are the numbers down here. What is the RF value of dye A? And again, want your answer in 2 significant figures, please. How far gas travels up the cylinder? Don't know what that means. Oh, you're talking about gas chromatography. Ah, yes. Yeah, that's not one of them. For those of you who are interested in why gas chromatography is more advantageous, it's more accurate, it's more sensitive, it uses smaller quantities of our samples, so we don't have to waste that much if we have created only a small amount of substance, but we want to see what it's made of. We don't have to use loads of it. We only need to use small samples. It is quicker and faster, more rapid than paper chromatography, and we can link it to a mass spectrometer, which is essentially just I'm not sure if you guys have heard of it. It's a really cool machine. I used it a lot at uni, which works out the sort of relative atomic masses of the individual substances, so we can split it up in the gas chromatography, and then we can use that to identify instantly using a mass spectrometer what those individual parts weigh, and so therefore what they might be. You'll learn all about that in probably A level, or if you go higher than A level. But we've got only a couple minutes left. You guys have been doing really well. So let's just get some answers for this question. Some people have chucked that on. Love to see it. Let's get a couple more. Come on, guys. More answers in the chat. You've been slowly putting less and less answers on the chat. I feel like it's probably because you've gotten used to this now, and it's fairly easy once you get used to it, because it's just always basically the same thing. So I assume that's why less people are chucking answers on. But yeah, really, really great stuff today. Let's go through it. And as I say, RF values, once you know what to do, nice and easy. So again, we do our distance to the die, which is 2.8 centimeters. None of you were thrown off by the fact they use centimeters in this one instead of millimeters like the other two. Absolutely good. As long as these two are in the same unit. So if distance to die A is in centimeters, but the distance to the solvent front is millimeters, then you'd have to change one of them to either centimeters or millimeters, so they're the same unit. But when they're both the same anyway, it doesn't matter because we're doing ratios. So we do 2.8 divided by 8.2. Love that it's the inverse. And the answer, I think, is, everyone said, was 0.34. To two significant figures. And that is 3 marks there. Easy stuff. See how easy this can be. If this comes up in your exam, you could get so many nice, easy marks on a question like this. I hope you guys appreciate that. But yeah, really well done today, guys. And we'll be moving on and covering some more analysis techniques next lesson. I cannot wait.
All right, that was really great. Well done, everybody. And we're going to do some Kahoot, and we're going to compete. And we're going to do some revision on organic chemistry. And Will might join us.
Hey, how's it going?
Good, good. How's it going with you?
Yeah, I'm good, thank you. Not too shabby.
Good to hear, good to hear.
I am going to share my screen in the meantime. Here we go.
What a nice boy Lee is. He appreciates everything I do. I do. That's touched my heart. That's lovely.
Yeah. I could pass you a tissue, but I don't think we have that type of technology yet.
Yet. I like your use of the word yet. It's coming.
Yeah.
Brilliant.
Right. Oh, nice. Can see you guys joining in. I'm gonna put this sound up. Because I think Kahoot sounds much fun.
Oh, jeez.
Oh, I think I'm lagging.
That was loud.
Is it lagging? I think it's because I'm sharing the screen as well.
Yeah, you've frozen a little bit.
Yes.
Oh.
Yeah,
Right.
Ryan's moving around. So I'm getting the sense that it's not
Yeah.
me.
Yeah, I think it's because
Yeah.
I'm sharing the screen. Sometimes it does that.
Yeah, that's a
nice.
lot of
We have-
Wi-Fi.
Yeah, and I'm like home, so I think there are 2 more people using it, and I'm like at the back, so I'm not like near the Wi-Fi. But yeah, I'm gonna kick us off, and I'll leave it open. So
All right, let's do this.
Super. Okay. Oh, we only have 3 minutes, guys, because I think it's only 12 questions. It gave us 3 minutes. I should have adjusted that.
I'm not joining in because I think it's messing up my Wi-Fi.
Is it?
Oh,
okay.
no.
Yeah.
They're gonna have
More.
to win that. How's your weekend?
Pardon?
How's your weekend?
Yeah, good. Thank you. What did I do? Walks. Fixing up my car.
Nice.
No, it was nice. It was nice. The weather was decent. Found a good walking spot with a panoramic view of Brighton. So that's good.
That sounds
Oh,
lovely.
nice. That's pretty cool.
Yeah.
Yeah. I went hiking like in Dale's Dyke.
Oh yeah. Yeah.
Oh,
Like,
nice.
It's pretty good.
Nice.
I really wanted to see the sunset, but my boss was just like, either I take it or I have to wait a whole hour. And I
Wow.
had to leave just before the sunset. And I was like, yeah, that was fun. It was fun going up there.
That's good. I've seen people gliding around there, like they're in parachutes, but they can sort of
Ooh.
fly around.
That's so cool.
It is
That
really,
sounds-
really cool.
Yeah.
Yeah. Yeah. On my walk, though, I had to walk through a golf course. It was like a part of the walk,
Okay.
and so I had to
Oh.
dodge like golf balls. Pretty intense.
Proper adventure.
Sorry.
Right, you guys are like toe to toe, 6 and 7, and just about 20 seconds. I'm assuming I'm frozen. 'Cause I can see my Wi-Fi signal.
Mhm.
Ooh,
Oh,
oh.
oh.
I
How'd
think
we do, owls?
Who
Turkey,
won?
you got. I thought we would have gotten like better scores because we've been doing this past couple of weeks. Okay, I'm gonna stop sharing there. But yeah, well done,
Ooh.
everybody.
Well
Well
done.
done.
Thank you, Mr. Ryan. For
Yeah, I'll
Yeah.
see you all tomorrow. Except Will. Bye,
Yeah.
Will.
See you, Ryan.
Bye.
All right, take it. I will see you guys in a minute.
All right. So today in maths, we are going to look at changing recurring fractions into recurring decimals into fractions. That's what we're looking at today. It's sort of one thing difficult to wrap our heads around. Once we wrap our heads around, it is fine. So let's look at an example. So the question might be, write 0.234. It's recurring, right? Dot on the 2, dot on the 4, as a fraction. So what we do is we name our decimal and we call it S. Then we would say, okay, so 1000S is 2.34.234 recurring. S equals 0.234, so 999S is just 234. And then suddenly we have a number we can work with that doesn't have recurring decimals. So I think I'm lagging a little bit. Let me know in the group chat if I'm lagging or if it's coming through all right. Because I think I can always change my Wi-Fi. Okay, so that's one example of how to do this. Another example is this. So we write 0.61, but this is just with the 6 recurring this time. We equal that to S. We say 10S is 1.6, 100S is 16.6. Therefore, 90S must be 15. So then we do 15 divided by 99 to find S or find 0.16. Okay, let's do some examples. So my question for you is, what is 0.2555 or 0.25 with the 5 recurring as a fraction? What is 0.25 recurring as a fraction? Okay. Does anyone know? Any ideas on this one? (23/90) got 26/100. Interesting. So got a couple through. 23/90. Cool. Cool. Okay, well done, guys. 3/90. Nice. So we've got some answers coming through. Awesome. Awesome. Cool. All right. I'm going to go through this one. It looks like we're feeling pretty confident with it. So here's a whiteboard. Write 0.25 recurring as a fraction. Can we zoom in on the whiteboard? That'd be great. So we know that we're going to equal this to S, so 0.25 recurring as S. So we're going to say that 10S is 25.5 recurring, like that. We know, so that is 100S. We know that 10S is equal to 2.5 recurring. So what we do is we take 100S and we take away 10S. So we do 100S, take away 10S equals 90S, which is 25.5 recurring. Take away 2.5 recurring equals 23. So 23 equals 90S. 23 equals 90s. So, of course, S or 0.255 recurring, right? Because we equaled that to S, equals 23 over 90. So well done if you got 23 over 90. 10 and 100 come from, yeah, so this is the technique we use. We times it by 100 to get 25.5 recurring, and by 10 so that we can get the 2.5, just so we can take one away from the other and get rid of those recurring numbers, because we can't turn it into a fraction because of the recurring numbers, right? So that's why we take 10 and 100s, take them away, just so we can end up with this nice 23 that we can use instead. Okay, nice. Let's have a look at the next question. So, the next one, prove algebraically that the decimal 0.25. We've done that one. Ooh, maybe you didn't see the fraction. What is the fraction? What is 0.17 recurring equal to? What is 0.17 recurring equal to? Give it to me as a fraction. Well, 7 as a fraction. Yeah, so it's very similar. So it's not with every single question, but it's very similar for every question, if that makes sense. Not like exactly the same, but very similar. Like sometimes you might need to times it by 1,000 and just take away one S from it. Cool. Got some answers in the chats. Nice. Lots of people interacting. I love to see it. That's great. Keep doing it. I'm going to give it another sort of second. Yeah, well done, Rain. Great job. Let me know if you guys agree with Dylan, Nor, Joshua, Lee, and Rain. All right. You were right. Good job. Good job. So what we do is we equal 0.1. I'm just going to write it like this because I find it useful to see. Equals S. Bring that out a tad. So we do 100S and we find 10S because we want to get those recurring numbers off, right? So it'll be 17.7 recurring would be equal to 100S. 1.7 recurring would be equal to 10S. And so 90S would be equal to 16. So I've got 16 equals 90S. Okay, so now we need to do 16 over 90. 16 over 90 equals S, or 8 over 45 when it's simplified equals S. So yes, there we have it, 8 over 45. And we've shown that 0.17 recurring equals 8 over 45. Got the number 16. Yeah, cool, nice, great. Yes, you got up to this point. Wonderful. So yeah, that means 90. That's 90 of times 0.1777, right? and we're trying to find that as a fraction. So we've basically done 90 times this has got to this, right? But we've done that by doing 100s, take away 10. By doing 100 of them and taking away 10 of them. And so once we're in this situation, though, we know that 16 equals 90 of them. We can turn it into a fraction. We can use 16 divided by 90. Simplify it, 8 over 45. Great. If you don't understand it completely, I mean, it looks like everyone's at least along the right lines. If they've not got it, it looks like we're making progress to get there. And we're going to do plenty of examples, so you'll definitely get there by the end of the session. And they're not all exactly the same. So do stick around because, yeah, they do get more complicated. So this one, let's do this one. Tell me what it is in the group chat. Pretend that I haven't shown it. You the answer. Go through it. See if you can get the right answer. Yeah. Oh, I'm 16 over 19. Yeah, exactly. Yeah. Great job. Love to see that, Zara. Well done. So we've got 17 over 7 over 10. Okay, people are agreeing. Speedy bunch. Speedy. Yeah. 0.38 equals S. I'm just going to jump to... No, I'm going to go through it just in case people are watching that don't get it. We got 38.8 equals 100 S. 90 S would be, sorry, we need to do 10S first. 10S equals 3.8 recurring. I'm just going to scroll down a little bit here. So that around equals 10S. So 90S equals 35. Right? Yeah. So S equals 35 over 90. We're going to want to simplify that. And we can divide it by 5. Good job, guys. Divided by 5, and I get 7 over 18. Wow, everyone's speedy today. You guys are doing really well. This is great. Josh, hands down, pretending you didn't see the answer. I hope we are going through it and we're not just seeing the answer and putting it in. Yeah, great job. All right, let's find one that is slightly different. Okay, what's the possible value of X? Gosh, there we go. What's the possible value of X? We're doing question number 9. Um, 26 over 70. So I'm just taking a minute. All right, this is interesting. Good job to Joshua and Rain. Joshua said, "I will not be held responsible for making for people making silly mistakes." Okay, guys, what does the question say? Read the question again. Read that question again. I'm trying to figure out. Okay, cool. X is not 0.4. Yeah, exactly. Well done, guys. It says possible. Let's read the question again. The possible value, singular. The one that is not 0.4. Yeah, can you see? X is not equal to 0.4. Which one's the possible value? It's 26 over 70. That's the one that is not a possible value. 13 over 35. That'll simplify to the best. Yeah. Guys, am I back? So Likith has already got the value to the next one. So yeah, which one is the largest number? Let me know in the group chat. OPM's got an answer in as well. Write these out. Yeah. So it's basically between 0.5 recurring and 0.55, isn't it? Because 0.5 is going to be smaller, 0.54 is going to be smaller as well. So it is 0.5 recurring. Yeah, not 0.55, 0.5 recurring. Ooh, did we get that? Because 0.5 recurring is bigger than 0.55, right? Because that is just 0.55. This is going to go on and on and on. 0.555, yeah? This is bigger. Yeah, exactly. So well done if you got that. Okay, which fraction is equivalent to 4.75? Which fraction is equivalent to 4.75? So it said 0.5. Circle the largest number. That's 5.5. That's 5 recurring. Yeah. It's got a little dot on top. Sorry if you missed that. Joshua's got an answer in 19.4, 19 over 4. Yeah, people are agreeing. Nice. Lovely to see all of the interaction. Yeah, absolutely. It is 19 over 4. You could just start by timesing 4.25 by 4. It'll get 19. So you know that it is 19 over 4. You just times this by 4. All right. I'm just going to switch my Wi-Fi just to see if that helps. So I might disappear and come back. Okay, I'm back. I'm back on the original Wi-Fi. It'll be fine. It'll be fine. Okay, what are these numbers in the order of size? Yeah, people are doing it really fast. It's almost suspicious. Almost suspicious. It will be fine, then freezes again. Am I back now? Keeps cutting out. Is it okay now? Are we good now? .67. So it's these numbers in order of size. Yeah. Not seeing any numbers. So everyone's saying 0.67. Ah, interesting. Okay. Yes. Decimal that's the closest value of 2/3 is 0.667. Okay, let's do these questions. So let's order these in order of size. What have we got? What do you guys reckon? Smallest to largest. Can we see it now? You can see the right question now, yeah? Some technical issues on my end. Okay, this is all about what number would come next, okay? Because right now we can just see the first 3 decimals, but there are more decimals to follow. So this one, for example, would be 0.2464646, okay? But it only matters the number that's coming after it. So this one would be 0.246 recurring. So that would be 66. Obviously, it goes without saying, there's going to be more numbers after that, right? Okay, so this next number would be 0.246246. So we're just looking at the order of these recurring numbers. But the 2 is the only one that matters in this case. And then this is just 0.246. I've just put the 0 there just to show that the 4th decimal point would be 0. Okay, no worries, Tamina. We'll go through it. So which one? The smallest. This one is the smallest. Then it's this one. Then it's this one. And then this one is the biggest. The 0.246 recurring is the biggest. Can't turn recurring decimals into fraction. No, all right, we'll go through how to do that in 1 second. So what is 0.36 recurring as a fraction? 0.36 recurring as a fraction. I'm just going to try and do what I can to sort out the Wi-Fi. Okay. So we've got 4 over 11 for this one. So for this one, I mean, yes, well done for getting 4 over 11. If you're not going through it and you're just writing what it is, you are cheating yourself. So we're going to put S equaling the 0.3636. Recurring. We want 1,000 S. I'm going to go for 1,000. I'm going to work our way around from there, equaling, so that'll be 3.6, and we want it to be 36.6. I'm going to go for 100. So we want it to be 36.36. And then what am I going to do? This is like 36 recurring, right? I want to make sure that's clear. So I'm going to find 99s, because what we're trying to do is we're trying to cut off this bit here. This bit is what makes this question so difficult. So we're going to cut that bit off and just do 99s equals 36. Hopefully that makes sense. Don't understand the method. Okay, well, we're going to go through it and hopefully you'll understand. So what we want to do is get rid of the recurring part here. So 99s equals 36. Therefore, to find S, that will be 36 divided by 99. And then we can divide the top and the bottom by 9 to get 4 over 11. So that is our answer. S equals 4 over 11, or 0.36 recurring is equal to 4 over 11. Why is 99s 36? Because if you do 100s, take away S, you do this, take away this bit. So I'll highlight it so you can see this bit, take away this, and that will get you 99s, which is 36. Nice. Hopefully, if you've got questions, people will answer in the group chat as well, just in case I miss it. Sorry, Zara, I missed your message. Oh, so it's 36. So it's like 0.36363636, right? Maybe that's where the confusions come from. Sabina's got it. How do you know what time's it? Yeah, so we just want to figure out how to cut this bit off. So you're going to want to do 100 because you want it to be 36. You don't want it to be 10 because then it'd be 3.6363, and we can't take anything off of that. It's best just to do this by practicing. I'm not going to lie. So show that this recurring decimal, find the fraction. Same as usual, find the fraction. And we can figure this one out. Oh, nice one, Joshua. Joshua's making some progress. Yeah, if you find the method hard to understand, that's why we're going through it for a whole lesson. Basically, just doing the same or similar questions. Cool. Let me know what you get if you agree with Joshua. Hey, Christine. We're turning recurring decimals into fractions. If you've just turned up, this might be quite difficult to understand in the final 10 minutes of the lesson. I'm not gonna lie. Okay, Joshua, is that your final answer? So the final answer, has anyone got it? $44 over 111. So we've got to show so we want to take away one of those. So you said, okay, 1,000 of them would be 396.396. So we're going to take away one of them to find out that 999 of them equal 396. So then we can do 396 divided by 999 to get our answer. So let's go through this. I'm going to say S equals 0.396 recurring. That's meant to be a 3, believe it or not. Recurring. So 1,000 S equals 396.396 recurring. And the reason why I'm going to do just take away one S off is because that would get rid of this bit. We're just trying to get rid of the recurring part by taking away it from itself, in a way. So 999S equals 396. So S equals 396 divided by 999. So we can simplify that. Answer came in decimals. Okay, so we're trying to get it into a fraction. Okay. And then all we've got to do is simplify that. So I immediately think, okay, we can divide it by 3, similarly to how Joshua did it, which would be 132 over 333. And then we can divide that by 3. That's over. Divided by 3. And that will get us 44 over 111. There we go. Okay, let me know on a scale of 1 to 10, how confident are you feeling about this? Let me know on a scale of 1 to 10. Scale of 1 to 10. How do you feel about it? And then let me know the answer to this one. 9, 11, a few 6s, cool. All right, we'll do 1 or 2 more, depending on the time. And we'll see how they go. Okay. So let me know when you've got an answer to this one at the top of the page. Okay, give you guys some time to do it. See if you can really have a go. See if you can figure it out this time without me going through it. Yeah, and then I'll go through it. Got a lot of sixes. Cool. Thanks for posting the numbering, guys. What is after the equals sign? Oh yeah, no. So just show that this is a fraction. It is the fraction, but I'm getting you guys to type out the answer instead of like the whole method. Just because it's easier in the streaming format. So yeah, let me know if you get an answer for this one. Okay, let's run through this and then we'll finish. Haven't got any answers in the chat for this one. So we're going to equal this 7 to S. So that means that 1000 S is 417. 417 is 9,000 S. So 417 equals 999 S. Then we do S equals 417 divided by 999. And then we've got to simplify that down. And at this point, we know it's going to simplify to make 139 over 333. So S equals 139 over 333. Well done if you got that, guys. Okay, we are going to finish maths there and do a break. So I'm going to hand over to Edie to do that. Then we're going to do some physics. I'm hoping that clearing these maths tabs might help with my slight lagging.
Right. It wasn't that disturbing though, so I don't know. From my side, it wasn't too disturbing, so it was fine. And we're gonna do some physics Kahoot. Yeah, we're gonna do some physics Kahoot, but I think I did the wrong mode. Just bear with me. I'm just gonna double check.
That's all good. Yeah, let me know if you guys want to go over that topic again. It looked like loads of people got it at the start, and then at the end, other people came in like, no, I don't understand this. So it's thanks for letting me know. But yeah, let me know if you want to go through it again at some point, and we absolutely will.
Yeah, I thought at first like everybody was just kind of like whisking through it. Well, okay, this is our Kahoot. Am I lagging?
I think so, but I think I'm also lagging a little bit as well.
It's not a good day. Right. My phone's not in there. Right. Okay, I'm gonna put the link. You can use the link or just do the QR code or don't do it, and then do the numbers. All right, I can see you guys popping in. But no, I was like, at first, you guys were like really going really, really fast, and then I don't know what happened. The people who got it
Yeah.
also was a bit confused.
Yeah, I think a few people knew how to do it from the get go, and then a few people.
Oh,
It's
yeah.
quite a difficult one to understand, but once you understand it, it's easy. It's one of those.
Yeah, it clicks. Yeah, and we had like 42 people at some point as well. So we had some big group and big responses. It was really great.
Awesome. Love to see it.
Yeah. Okay, I'm gonna start it and leave it open, so you can join in. Do you think today's gonna be the day? It's some like easy questions, I think.
Make sure you put the symbols you see in the group chat when it comes to it, guys.
And we don't have good Wi-Fi, so nobody's helping you. You guys are on your own, so make us proud, yeah?
Yeah.
And put this aside. I can see the chat.
Yeah, make sure you stop spamming the chat with those heads, Joshua. Otherwise, you'll be put in timeout again.
What are we doing in physics?
In physics, we're going to look at stopping distances.
Oh, okay, nice. And most of these questions are about like velocity and weight
Awesome.
and some force and stuff like that.
Brilliant. Oh, people saying lag from the shark.
Is it lagging?
It's just a really weirdly moving shark,
Yeah.
whale, crocodile monster, you know?
Yeah. It's whatever is going to be the next evolutionary thing. That was, I thought.
Yes.
You guys made it. Okay, you're gonna have to try
Yeah.
again. You're gonna have to try again. It's the same question, so if you put it quickly, you'll be fine.
Yeah. You got this, guys.
Got this. 3 minutes.
That's good.
More than
How was
enough.
your weekend, Didi?
It's been good. I've moved back home.
Oh, wow.
So Saturday we just like drove. We're like driving crazy. So we're on the road from. Well, I was on the road from 11, but the person that was picking me up was on the road from 7 all the way to midnight, which is crazy.
Wow.
But yeah, I decided to go back because I was tired of paying rent.
Yeah.
So
Yeah.
yeah, it's fun. It's a fun. Yeah, I think I'm gonna miss Brighton though.
Yeah. That's cool. That's cool. I mean, yeah. Where are you now?
London, kind of
Oh,
East London. Yeah,
Nice.
not
Cool.
too far.
My wife grew up in Spitalfields, like around
Oh,
Spitalfields.
okay.
Yeah.
Yeah.
Yeah, got married in East London.
Is it? When did you get married? Ooh, okay. Who's telling us? Daniel, if you put it on the chat.
Come on, Daniel, you got this.
Yeah.
Yeah, we got married opposite Spitalfields Market in a big Christ. It's called Christchurch, Spitalfields.
Oh, okay.
Yeah.
Fun. And then you moved to Brighton. Have you always been in Brighton?
Yeah, we were in Brighton, but she grew up in that church, and it's like a crazy venue. So we thought we'd take advantage of that.
Definitely.
Her parents live like 2 minutes down the road from the church. So. Yeah.
Fun. Okay.
Are we gonna make it?
Yeah, I don't think so.
Gonna get eaten again. Sad times.
Sad times.
10
We're still in
seconds
level
left.
1 as well.
Didn't know we'd be eaten by a big shark crocodile creature this evening, but it happened.
It happened. I feel like you'd just be wrong at this point if we escape. It's just Okay, we can try again at least.
At least the crocodile
3
shark
seconds.
ate well this evening.
Yes.
There's always people who bottle it, so why try, says Joshua. Sometimes. Maybe the tower one works a bit better.
Yeah. It's just that I didn't want to give up. Like I wanted us to go to the finish one, but I guess the tower one. Nobody's gonna be behind.
Let's go. We'll see.
Yeah. I mean, it was 30 seconds, so I don't even think that we have a chance, to be honest. The time is over, technically. Can still try.
Go on, King Suhan.
Also, the fact that it's just quiet and it's just that sound, they just make it intense unnecessarily.
Yeah. Okay, it's meant to be like handcuffs, or kind of like handcuffs. Then light. A light. Or 10 seconds left.
Yeah. I mean, the game is actually over. It's just like...
Oh, was it lagging that much?
No. The game is still going, but the time was over while they were answering. So this is just for the sake of it.
Very sad. Very sad.
Yeah, it's actually sad. I was gonna clap, but it is sad. I'm gonna stop sharing that.
Cool.
Yeah, and hopefully we could learn better. And I'll see you guys in a minute.
All right. Let's do some physics, why don't we, while we're all here? All right. What is stopping distance made up of? What are the two factors that make up our stopping distance? Think about in a car, right? We're in a car specifically. We see something. Oh no, someone's walked in front of the road. What two things make up the stopping distance? Nice. So we've got the distance it takes to come to a halt when we slam on the brakes. But before that, well done for people who have said thinking distance. The distance the car goes in the moment it takes for our brain to process, oh my days, I need to slam on the brakes. So it's made up of stopping distance is made up of thinking distance and our braking distance. So I'm going to share my screen and we're going to get into it. So stopping distance, thinking distance plus braking distance. So our thinking distance is our reaction time between the driver seeing the hazard and applying the brakes. So my question for you, what factors affect thinking distance? What things could affect the distance we travel while we are thinking, whilst we are taking our time to react to the situation? What factors could affect how quickly we're thinking? Ash has gone straight for drugs. Yes, so intoxication, drugs and alcohol could affect our thinking distance, could affect our reaction times. Alcohol is proven to affect our reaction times negatively, give us longer reaction times. Sugar and caffeine intake might increase our reaction times. Tiredness, yes, absolutely. Our reaction times could be slower if we're tired, or it could take us longer to realize that there's a hazard in front of us if we're tired. Absolutely, yeah. Let's have a look. So we've got the big one. Did anyone see it? Big one. What factors affect the thinking distance? What factors affect the thinking distance? Okay, if I'm going slowly, the thinking distance is going to be smaller. If I'm going quicker, the thinking distance is going to be bigger. Okay, now the time it takes might be the same, but the distance traveled going faster is going to be more. Okay, so the speed of the car. So the factors that affect the thinking distance: speed of the vehicle, higher speed, further the vehicle will go during our reaction time. Okay, and then we've got our reaction time. So yeah, well done if you said alcohol, those sorts of things, tiredness. Yes, those can increase our reaction time, which is no good. Okay, cool. Now, what factors affect our braking distance? What factors affect our braking distance? Let me know in the group chat. I'll give you guys a second to write them in. What factors affect the braking distance? Yeah, so tiredness would be more reaction time. Same with drugs, but I think there might be like a lag there. Age. So this is now our braking distance we're talking about. Road conditions. Yes, absolutely, Joshua. The road conditions. So if the road is in a worse condition, it might take the car longer to stop, increasing the braking distance. Tire condition is a big one, depending on even how good the tires that you've got on your car are. Would affect our braking distance. The weather is a great one. Well done, Zara. Yes. So the weather, friction, right? So that's what all of this is affecting, right? If the tires are in worse condition. So yeah, obviously weather. If it's raining or if it's icy, it's going to take longer for the car to stop. So everything, all of those things about thinking about braking distance are to do with friction, or it's another one. Again, the speed the vehicle is going does affect the braking distance. Okay, so our speed. So the faster a vehicle travels, the longer it takes for the vehicle to stop. So we've got speed of the vehicle again. Road condition, if there's ice or if the road is wet, then the road becomes slippery. So this might cause the vehicle to skid. There's actually anti-lock braking systems in modern cars to stop the wheels from locking up. You might think that if the wheels suddenly come to a stop, that might be really good, sort of increase the friction. But it doesn't. It can cause the car to slide and be uncontrollable. So they've got anti-lock brakes in modern cars now. The condition of the tires, make sure it's got lots of tread left, lots of grip, and the brake condition. So what conditions, the condition of the brakes. So the brake pads needs to be in good condition, making sure they're not worn out or sort of too warm, actually. Okay, so how does braking work? Well, the brake pedal is pressed, causing the brake pads to be pressed against the wheel discs. This causes friction between the brake pads and the wheel. Work is done. Kinetic energy from the wheel is transferred to thermal energy in the brakes. In cases of extreme speed, very hard braking, pads might not work properly. The vehicle might also skid due to sudden deceleration. If you've ever watched F1, that's when the wheels lock up. Right? It's like, oh, they've had a bit of lock up there. It's never ideal. We want to make sure those wheels are always turning and never locked up and just sort of skidding across stationary. Leads to a lack of control, and it's also not efficient braking. Okay, so a car traveling at a typical speed makes an emergency stop to avoid hitting a hazard 25 meters ahead. So the car weighs 1 ton. What's the braking force needed to produce this deceleration? What is the braking force needed to reduce this acceleration? What are we thinking, guys? Any ideas? Give a little hint here. Suvert, interesting. Here's the equation we want to use to find the acceleration or deceleration. I'm going to say that our velocity is 25 meters per second, okay? Anyone got any ideas for the answer for this example here? Okay, so we are gonna want to find. We're gonna want to rearrange this here to find the acceleration, and then we plug that into force equals mass times acceleration. F equals ma. The mass is 1,000. If we rearrange this equation here to find a, put our values in. U is 0 because that's our final velocity. B is our initial in this case. So we've got 25. We rearrange this, finding out that force is mass times acceleration. So we've got 1,000 times 12.5, which gets us 125,500. All right. Let's look at our typical stopping distance. So from 30 miles an hour, our thinking distance will be 9 meters and braking distance is 14 meters. At 50 miles an hour, the typical thinking distance is 15 meters, braking distance is 38. 70 miles an hour on a motorway, our overall distance is 96 meters, with 21 of those being thinking and 75 being stopping. We'll have a look at these we'll have a look at this and then we'll do some questions. So as a vehicle speeds up, the reaction time of the driver remains roughly the same, but more distance will be traveled due to the higher speed. Braking distance increases at a greater rate the more speed a vehicle has. The work that needs to be done to stop a vehicle is equal to the car's kinetic energy, which is a half times mass times velocity squared. So as the speed doubles, the kinetic energy increases by a factor of 4. Thus, doubling the speed of the vehicle means 4 times the braking force is required to stop the vehicle. So there we go. Here's our graph of stopping distance over speed. Okay, let's do some questions. I want to keep this interactive. So, what are 2 factors that affect the braking? Let's do this one. So, a council decides to impose a 20-mile-an-hour speed limit in a town centre. The councillor says drivers can react more quickly at 20 miles an hour than they can at 30 miles an hour. Explain what is wrong with the councillor's statement. What is wrong with the councillor's statement? Let me know in the chat. What's wrong with this statement? So councillors said drivers can react more quickly at 20 miles an hour than they can at 30 miles an hour. What's wrong with that? Anyone there? Hey, Joshua, the thinking distance is affected by the driver's reaction time and by drugs. Yes, but that's not what we're looking for here. Okay, so the distance is affected. The speed doesn't affect the thinking distance. Okay. The reaction time can be affected by the factors. Okay, right. The speed does affect the thinking distance. Yeah? Because if you're going quicker, the time it takes you to think will be the same, but you're going to cover more distance in that time. Yeah? Does that make sense? So the speed will affect the thinking distance, but it will not affect the thinking time. Okay? So the time it takes to react will be the same. And he says the drivers can react more quickly at 20 miles an hour than they can at 30 miles an hour. No, the driver cannot react more quickly at 20 miles an hour than 30 miles an hour, but the distance traveled whilst they're thinking will be greater. Okay? Same amount of time, different amount of distance because of a quicker speed. Does that make sense to everybody? So reaction time can be affected by the fact the driver was under the influence. Yeah, no, it's nothing to do with that. So he can't react quicker at 20 miles an hour than 30, but the thinking distance will be less. Does this make sense? Let me know in the group chat. Does this make sense? Give me a yes or a no. The distance it takes will be more, but the thinking time is the same because of the difference in speed here. Yeah, making sense. Okay. Thanks, Dylan. Okay, let's do this next question. So if a driver has a reaction time of 0.4 seconds and the car is traveling at 20 meters per second, what's the driver's reaction distance? What is their reaction distance? We have the distance, we have the speed, and we want the time. Nope, we have the time and we have the speed and we want the distance. Okie dokie. Anyone got an answer here for our reaction distance? Anyone know what the reaction distance might be? Keep putting hints in. Anyone got an answer for this one? Not too difficult, guys. Omabola has got her answer in. Do you guys agree or disagree? Elizabeth agrees. Awesome. Yeah, great. So distance is speed times time. Our speed is 0.4 and our time is 20 meters per second. So our distance is going to be 8 meters. You get an extra point if you put in meters as well with your units. Okay, nice. Let's have a look at the next question. So some sources claim that self-driving cars will be available by the year 2040. Write down the equation relating reaction time, reaction distance, and vehicle speed. Reaction time, reaction distance, and vehicle speed. What did you say from the last question? Yes, so thinking the speed does affect our reaction time. No. Speed affects the reaction distance. Okay? It doesn't affect our reaction time. Yeah? Because you're going to react in the same given time in whatever speeds you're going at, right? But if you're going faster, that amount of time where you react, you're gonna travel a further distance. If you're going quicker, right? If you're going slower, the amount of time it takes for you to react, you're not going to be going as far. Reaction distance, time is distance divided by time, or we'll have a look. Yeah, it's just speed equals distance over time in disguise here, guys. Okay, does this make a bit more sense now? Yeah. Reaction time, reaction distance, vehicle speed. Vehicle speed equals reaction distance divided by reaction time. Yeah. Vehicle speeds equals reaction distance over reaction time. See if I can get that. Okay. It's just speed equals distance divided by time in disguise. Okay, so it takes an average person 1.6 seconds to hit the brakes if someone walks in the road in front of the car. Calculate the reaction distance in this scenario at a speed of 30 meters per second. So yeah, reaction speed is distance divided by time. Elizabeth would be correct. Nice one. I'm assuming that's what you meant. What do we think of this one, guys? Any ideas? Any ideas? So we're looking for distance. Elizabeth got an answer in the chat. Do you guys agree with Elizabeth? Let me know if you agree. Okay, cool. AJ, love to see it. Right, yes. So distance is speed times time, right? We're trying to find the distance. Our time is 1.6. Our speed is 30. So we're going to do 1.6 times 30, which is 48 meters. So if you've got 48 meters, well done. Give yourself a vigorous pat on the back whilst we do our next question. We're going to cover this one. Okay, let's do this one. So we have a graph, and it shows how the braking distance of a car driven on a dry road changes with the car's speed. So we need to draw a line on figure 1 to show how the braking distance of the car on an icy road changes with speed. So we're going to want to draw a new line here. I don't really have the capabilities of drawing a curved line. But what's going to happen on an icy road is the braking distance going to increase or decrease on an icy road. I'm going to say that again. Is the braking distance going to increase or decrease on an icy road? It's going to increase. That's right. So our braking distance is going to be more like this if it was a curved line. Wait, let me see if I've got options. No curved lines. Sad. So it's going to be more like this. All right. Okay. Something like that. There you go. See how the braking distance is big at a low speed. Yeah, you get the point. Let's have a look at number 2. So this graph shows the velocity of 2 cars and how they change from the moment the car drivers see an obstacle blocking the road. So which car has the smaller stopping distance? Is it car A or is it car B? Which car has the smaller stopping distance? Let me know in the chat. It's only about 10 minutes left. We can do it. We've almost made it. Almost made it. Which car has the smaller stopping distance? A asks Christine, well, do we agree with Christine or do we disagree? Let me know in the chat. A says Vivian as well. It is A. Well done if you said A. Well done, Christine and Vivian and AJ. The stopping distance is smaller because the time taken to react is smaller. Great. Good job. So one of the car drivers was on their phone and the other one was wide awake and alert. Which driver drove which car? Which driver was on their phone? Which driver was wide awake and alert? Was it vehicle A or vehicle B? Which one is which? So you're going to have to say which one's which. B is on there. Nice. Well done, Amabella. Yeah, absolutely. B is on their phone because they've got a longer reaction time. And this one was wide awake and alert. And so didn't need to take as long. Ah, I'm not yawning. You're yawning. There you go. I've even put a little circle there. Marvelous. So a different driver in car C has stopped a stopping distance of 15 meters and a thinking distance of 4 meters. What's their braking distance? What is their braking distance? Guys, be nice to Christine, otherwise you'll get booted. You will get booted. That's your first warning. All right. What is the braking distance of the driver in car C? What is their braking distance? What is their braking distance? Anyone? Okay, nice, easy one here. So we have an overall stopping distance of 15 meters. That 4 meters of that is the braking distance. So the rest is going to be, it's the thinking distance. So the rest is going to be the stopping distance, yeah? Our stopping distance is made up of our thinking distance, our 4, and our braking distance, which is 9, to equal our 15 meters over all. Okay, yeah? So 9 is our answer, yeah? Overall distance, 15 meters. Take away our 4 meters of thinking distance. That's our 9 meters of stopping distance. All right. Okay, we are... Joshua, sort yourself out or you'll get booted. Right. So, question 3A, we've got our reaction times of 3 people driving under different conditions. We have driver A, who's very tired, driver B, wide awake, and driver C using a hands-free phone. Okay, A, B, and C, let me know top to bottom which driver they are. So, starting with A. Starting with the top one, which one is this? Okay, yes. So this one on top has the furthest thinking distance here. So that is going to be A with our reaction time. It's going to have the longest reaction time, right? Because it's the furthest distance. So this is going to be car driver A. And then which one is this going to be? Which driver, B or C, has the second quickest reaction time, or the second furthest distance? Hopefully we're seeing this correlation here between reaction time and distance here. C, using a hand-free phone. Yeah, absolutely. So they've got the sort of the second furthest distance. So they're going to have the second quickest reaction time. And then so B comes here. So we can see that if your reaction time is quicker, your stopping distance is less, which is good. Okay, so what are two reasons as to why driver A would have the longest reaction time? Two reasons that driver A has the longest reaction time, and not given in the table. Two reasons driver A would have the longest reaction time. I'm looking for reasons that aren't given in the table. So why else could they have a longer reaction time? That's what I want to know. Why else might someone have a longer reaction time and therefore go a further distance before braking? He could be intoxicated. Yeah. Anything else? Yeah, so he could be tired. He could be distracted on his phone. And yeah, intoxication, drugs, or alcohol. Yeah. Good. Okay, so right, we'll hop onto this next one. Okay, what are our missing values? So an investigation is carried out to show how thinking distance, braking distance, and stopping distance are affected by the speed of a car. So we've got a thinking distance here, braking distance here. So fill in the gaps. What number is missing here? Let me know in the chat. What number's missing here? Brakes might be folded. That's also a good. A good answer. Right, what number's missing here in the table? So what's our thinking distance? What's our stopping distance made up of? Our stopping distance is made nice. No. Amazing. Well done. Yes. So our stopping distance is made up of our braking distance plus our thinking distance. So our thinking distance is going to be 6. And what number is missing here? Slightly more difficult calculation to do, but easily done by smart people like you. 36. Noor, do you guys agree or disagree with Noor? Agree with Noah, 36. So it's going to be the stopping distance take away the thinking distance. So it's going to be our 53 take away 15, which is 38. Yeah. So you've added 24. It's going to be 38. Yeah. Because our stopping distance is our thinking distance plus our braking distance. Okay, we are going to finish there. All done for the evening. Well done, guys, for making it through. I'm going to pass over to Edie to sign off.
All right, amazing. Yeah, thank you very much. Thank you both. I'll see you next week. And the rest of you, I'll see you tomorrow. And well done for staying this far. And yeah, well done for engaging in the chat as well.
All right.
See you next time.
Bye, everyone.